So, as part of our project in Free Elect 3, we are going to report trends in information systems. And now let's proceed with the Internet of Things and its benefits. The Internet of Things, or IoT, is a catch all term for the growing number of electronics that aren't traditionally computing devices, but are connected to the Internet to send data, receive instructions, or both. The IoT brings the power of the Internet, data processing, and analytics to the real world of physical objects. For consumers, this means interacting with a global information network without the intermediary of a keyboard and screen. Many of their everyday objects and appliances can take instructions from that network with minimal human intervention. IoT can provide you the ability to collect data from the network and use advanced analytics to uncover business insights and opportunities and reduce operational costs. IoT capabilities allow you to set up and roll out new products and services, often quickly. Use data collected by IoT devices to help predict what your customers need and speed planning and delivery of new revenue generating offerings. And now we are going to explain a short explanation for artificial intelligence. Artificial intelligence, also known as AI, refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. The term may also be applied to any machine that exhibits traits associated with a human mind, such as learning and problem solving. The ideal characteristic of artificial intelligence, or AI, is its ability to rationalize and take actions that have the best chance of achieving a specific goal. A subset of artificial intelligence is machine learning, which refers to the concept that computer programs can automatically learn and adapt to new data without being assisted by humans. Deep learning techniques enable this automatic learning through the absorption of huge amounts of unstructured data, such as text, images, or video. And here are some examples of artificial intelligence, or AI. We have Google Maps and ride hailing applications, face detection and recognition. We also have text editors or autocorrect, search and recommendation algorithms, chatbots, digital assistants, social media, and also we have e-payments or electronic payments. And let's discuss the blockchain in the financial industries. Bitcoin, which is very well known, is based on a distributed ledger, or rather a specific kind of distributed ledger or a blockchain. Bitcoin's ledger was the first blockchain, but the technology has begun to spread across the global economy. The reason blockchains let you keep thousands of strangers honest and consistent. What is blockchain? It is a rare that the technology of industry comes up with a term that describes in the simplest terms what exactly a new technology it has created actually does. Blockchain is one such example as it is exactly what the name suggests. It is a technology that allows blocks of information to be created and stored in a chain. Each time a new block is created, it is added to this chain to form what has been called a digital ledger. While it has been possible to create digital ledger before, blockchain ledgers have a number of revolutionary benefits over traditional approaches. And now we have blockchain and financial services. You are likely wondering whether to invest in the development of blockchain. Well, don't wait too long because many of your peers in the financial services sector are certainly doing that. A MarketWatch report states that total investment in blockchain in the banking and financial services sector amounted to $2.3 million in 2018. The report states that this spending will likely reach $17.47 million by the end of 2025, with a CAGR of 33.6% during the 2019 to 2025 period. It is worth noting note important statistic here, and this one gives the best indication of potential ROI of early investment in blockchain. Banks and financial services institutions are investing both in blockchain platform and services. Market experts are predicting that the services component will grow significantly. An Allied Market Research reports project a CAGR of 76.1% throughout the period of 2019 to 2026. This is staggering and is unmatched by nearly any other industry vertical.
How blockchain is changing finance. There are a number of key areas where companies can use blockchain in finance software and system, while banks are reluctant to openly discuss potentially uses of blockchain. A number of them have um, recently commissioned studies to identify exactly where they can. These include Citibank, Credit Suisse, and the World Economic Forum. Blockchain benefits for the finance industry. Instant settlements, improved capital optimization, improved contractual performance due to a smart contracts, increased financial solution in terms of crisis, reduce error handling, and improve transparency. Next slide. Next slide. Discuss privacy and security in the digital age. A serious problem of security has developed because of the popularity in the use of the internet for all kinds of communications by both individuals and companies. This potential security issue has forced many to evaluate the need for even connecting to the internet. Connecting has many benefits, but it is worth the risk of possible loss of confidential information, damage to files and system, hackers, and viruses. The implication of rapidly expanding internet technology on society's desire to maintain privacy and security of information. This is accomplished by discussing a variety of issues, including an overview of privacy and security issues, encryption as one potential solution to the privacy and security issues, and congressional legislation affecting privacy and security. Next slide. Okay. Explain Industry 4.0 and its benefits. What is 4.10? Uh, Industry 4.0 refers to the fourth industrial revolution, although it's concerned with areas that are not usually classified as industry application in their own right, such as smart cities. What is the fourth industrial revolution? The first industrial revolution came with the advent of mechanization, steam powered, and water power.
Jam imo kami off.
This was following by second industrial revolution which revolved around the mass production and assembly lines using electricity. The third industrial revolution came with electronics, IT system, and automation, which led to the fourth industrial revolution that is associated with cyber physical system. Next slide. Industry 4.0 technologies. Generally speaking, Industry 4.0 describes the growing trend towards automation in data exchange and technology and processes within the manufacturing industries, including the Internet of Things or the IoT, the Industrial Internet of Things or the IoT, Cyber Physical System or the CPS, smart manufacturers, smart factories, cloud computing, cognitive computing, artificial intelligence. Next slide. Next slide, please. Thank you. Benefits of Industry 4.0. The benefits of Industry 4.0 include improved productivity and efficiency, better flexibility and agility, and increased profitability. Industry 4.0 also improves the customer experience. While smart factory technologies are interesting and exciting, the benefits of Industry 4.0 should always be central to any discussion. After all, any investment you make in technology, improve manufacturing processes, or enhance systems should deliver a return. With Industry 4.0, the ROI opportunities are significant because of the benefits the technologies offer. This includes technologies that improves automation, machine-to-machine communication, manufacturing oversight, and decision making. Here are the main benefits of Industry 4.0 to your production lines in your business. Improve productivity, improve efficiency, increase knowledge sharing and collaborative working, flexibility and agility, makes compliance easier, better customer experience, reduces cost, creates innovation opportunities, higher revenues, increase profitability, and getting a return on investment. Relate Education 4.0 with Industry 4.0. Future workers will need to be highly trained and emerging technologies, but also importantly, in the values associated with using those technologies in the future. We must not only possess the ability to develop the technology, but also to whether when and whether to use that technology kind of thing. That kind of thinking is both reflective and interdisciplinary. School must reinvent themselves quickly. They need to adapt the demands of the RI4 and have the obligation to come out of its shell. Its hermetic spaces and try to give as many opportunities as possible by creating the adequate context for students to be prepared for the future jobs. The problem in the future could not be lack of employment but the shortage of skills that the new jobs will demand. Students need to understand how they can correlate and use and apply different knowledge in diversified contexts, what they are really meant and how they can create synergies among different subjects to develop or create something that connects to the real world. This takes us to another very important point. Students need to work in a framework of projects and from there they need to collaborate with their colleagues, with their teachers and with the outside world. They need to develop new ways of communicating. They need to be put in the front of complex situations to develop critical thinking and complex problem solving and to learn how to be imaginative, creative, adaptable, flexible, and develop brain plasticity.
Next, in other words, Industry 4.0 will require the world to produce a new kind of worker, a knowledge worker. Tomorrow's industry leaders and managers must possess new skills sets to adapt, to manage, and to take advantage of Industry 4.0. They must be critical thinkers, problem solvers, innovators, and communicators and provide value driven leadership. They, they must be able to see beyond the technology at play to the implications for society for the use of the technology. These traits define the knowledge worker. They must know the technology but be able to meet and solve all aspects of the challenges engendered by this technology. This kind of leader requires a new approach to education. As Alex Gray 2016 states, change won't wait for us. Business leaders, educators, and governments all need to be proactive, proactive in upskilling and retraining people so everyone can benefit from the fourth industrial revolution. So we have the application to create the models and context to allow it to happen. Otherwise, we will have a generation with no skills shortage for the new demands of the labor market, and that will become a big problem to society. Explain big data and how it is used in analytics. What is big data? Big data is a term that describes the large volume of data, both structured and unstructured, that inundates a business on a day-to-day basis. But it's not the amount of data that's important. It's what organizations do with the data that matters. Big data can be analyzed for insights that lead to better decisions and strategic business moves. The use of big data is becoming common these days by the companies to use of the the use of big data is becoming common these days by the companies to outperform their peers in most industries. In most industries, existing competitors and new entrants alike will use the strategies resulting from the analyzed data to compete, innovate, and capture value. Big data helps the organizations to create new growth opportunities and entirely new categories of companies that can combine and analyze industry data. These companies have ample information about the products and services, buyers and suppliers, consumer preferences that can be captured and analyzed. Next, while the term big data is relatively new, the act of gathering and storing large amounts of information for eventual analysis is ages old. The concept of gained momentum in the early 2000s when industry analyst Dow Lenny articulated the now mainstream definition of big data as the three V's volume organizations collect data from a variety of sources including business transactions, social media information from sensor or machine to machine data. In the past, storing it would be a problem, but new technologies such as Hadoop have lessened the burden. The name big data itself is related to a size which is enormous. Size of data plays very crucial role in determining value out of data. Also, whether a particular data can actually be considered as a big data or not is dependent upon volume of data. Hence, volume is one characteristic which needs to be considered while dealing with big data. Velocity. Data streams in at an unprecedented unprecedented speed and must be dealt within a timely manner. RFID tags, sensors, and smart metering are driving the need to deal with torrents of data, torrents of data in near real time. The term velocity refers to the speed of generation of data. How fast the data is generated and processed to meet the demands determines real potential in the data. Big data velocity deals with the speed at which data flows in from sources like business processes, application logs, network and social media sites, sensors, mobile devices, etc. The flow of data is massive and continuous. Next is variety. Data comes in all types of formats, from structured datasets. Examples can be seen here, here, and here. Numeric data in traditional databases to unstructured text documents, email, video, audio, stock, stock sticker data, and financial transactions. Variety refers to heterogeneous sources and the nature of data, both structured and unstructured. During early days, spreadsheets and databases were the only sources of data considered by most of the applications. Nowadays, data in the form of emails, photos, videos, monitoring devices, PDFs, audio, etc. is also being considered in the analysis applications. This variety of unstructured data poses certain issues for storage, mining, and analyzing data. The next is, what is big data analytics? Big data analytics is the use of advanced analytic techniques against very large, diverse big data sets that include structured, semi-structured, and unstructured data from different sources and in different sizes from terabytes to zettabytes. The amount of data in today's world is staggering, but big data offers vast opportunities for businesses, whether used independently or with existing traditional data. Data scientists, analysts, researchers, and business users can leverage these new data sources for advanced analytics that deliver deeper insights and to power innovative big data applications. Some common techniques include data mining, text analytics, predictive analytics, data visualization, in machine learning, statistics, and natural language processing. With big data analytics, you can ultimately fuel better and faster decision making, modeling and predicting of future outcomes, and enhance business intelligence. As you build your big data solution, consider open source software such as Apache Hadoop, Apache Spark, and the entire Hadoop ecosystem at cost-effective, flexible data processing and storage tools designed to handle the volume of data being generated today. Discuss robotics. What is robotics? Robotics is the intersection of science, engineering, and technology that produces machines called robots that substitute for or replicate human actions. Pop culture has always been fascinated with robots. R2D2, Optimus Prime, Wall-E. These over-exaggerated humanoid concepts of robots usually seem like a caricature of the real thing. Or are they more forward thinking than we realize? Robots are gaining intellectual and mechanical capabilities that don't put the possibility of a R2D2 like machine out of reach in the future. As technology processes, so so does the scope of what is considered robotics in 2005. 90% of all robots could be found assembling cars in automotive factories. These robots consist mainly of mechanical arms tasked with welding or screwing on certain parts of a car. Today, we're seeing an evolved and expanded definition of robotics that includes the development, creation, and use of bots and explore Earth's conditions robots that assist law enforcement, and even robots that assist in almost every phase of healthcare.
Type of robots: pre-programmed robots, humanoid robots, autonomous robots, teleoperated robots, augmenting robots, applications of robotics, helping fight forest fires, working alongside humans in manufacturing plants known as cobots, robots that offer companionship to elderly individuals, surgical assistance, last mile package and food order delivery, autonomous household robots that carry out tasks like vacuuming and mowing the grass, assisting with finding items and carrying them throughout warehouses, used during search and rescue missions after natural disasters, landmine detectors in war zones, uses of robots, manufacturing, logistics, home travel, and healthcare. The 5G concepts and uses. Next, next, next. What is 5G? 5G is the fifth generation of mobile networks, a significant evolution of today's 4G LTE networks. 5G has been designed to meet the very large growth in data and connectivity of today's modern society. The Internet of Things, with billions of connected devices, and tomorrow's innovations, 5G will initially operate in conjunction with existing 4G networks before evolving to fully standalone networks in subsequent releases and coverage expansions. In addition to delivering faster connections and greater capacity, a very important advantage of 5G is the fast response time, referred to as latency. Latency is the time taken for devices to respond to each other over the wireless network. 3G networks had a typical response time of 100 milliseconds. 4G is around 30 milliseconds and 5G will be as low as 1 millisecond. This is virtually instantaneous, opening up a new world of connected applications. Next slide. Uses of 5G. 5G is used across three main types of connected services, including enhanced mobile broadband, mission critical communications, and the massive IoT. A defining capability of 5G is it is designed for forward compatibility or the ability to flexibly support future services that are unknown today. Enhanced mobile broadband. In addition to making our smartphones better, 5G mobile technology can usher in new immersive experiences such as VR and AR with faster, more uniform data rates, lower latency, and lower cost per bit. Mission critical communications. 5G can enable new services that can transform industries with ultra reliable, available, low latency links like remote control of critical infrastructure, vehicles, and medical procedures. The massive IoT 5G is meant to seamlessly connect a massive number of embedded sensors in virtually everything through the ability to scale down in data rates, power, and mobility, providing extremely lean and low-cost connectivity solutions. Discuss serverless computing.
What is serverless computing? Serverless computing is a method of providing back-end services on an unused basis. A serverless provider allows users to write and deploy code without the hassle of worrying about the underlying infrastructure. A company that gets back-end services from a serverless vendor is charged based on their computation and do not have to reserve and pay for a fixed amount of bandwidth or number of servers. As the service is auto-scaling, note that despite the name serverless, physical servers are still used, but developers do not need to be aware of them. In the early days of the web, anyone who wanted to build a web application had to own the physical hardware required to run a server, which is a cumbersome and expensive undertaking. Then came cloud computing, where fixed numbers of servers or amounts of server space could be rented remotely. Developers and companies who rent these fixed units of server space generally over purchase to ensure that a spike in traffic or activity that will not exceed their monthly limits and break their applications. This means that much of the server space that gets paid for can go to waste. Cloud vendors have introduced auto-scaling models to address the issue, but even with the auto-scaling, an unwanted spike in activity, such as a DDoS attack, could end up being very expensive. Serverless computing allows developers to purchase back-end services on a flexible pay-as-you-go basis, meaning that developers only have to pay for the services they use. This is like switching from a cell phone data plan with a monthly fixed limit to one that only charges for each byte of data that actually gets used. The term serverless is somewhat misleading as there are still servers providing these backend services, but all of the server space and infrastructure concerns are handled by the vendor. Serverless means that the developers can do their work without having to worry about servers at all. What are back-end services? What's the difference between front-end and back-end? Application development is generally split into two realms, the front end and the back end. The front end is the part of the application that users see and interact with, such as the visual layout. The back end is the part of that the user doesn't see. This includes the server where the application's files live and the database where user data and business logic is persisted. What kind of back-end services can serverless computing provide? Most serverless providers offer database and storage services to their customers, and many also have function as a service platforms like Cloudflare Workers. FAAS allows developers to execute small pieces of code on the internet edge. With FAAS, developers can build a modular architecture, making a code base that is more scalable without having to spend resources on maintaining the underlying backend. So, what are the advantages of serverless computing? Lower costs. Serverless computing is generally very cost effective as traditional cloud providers of backend services. Server allocation often results in the user paying for unused space or idle CPU time. Simplified scalability. Developers using serverless architecture don't have to worry about policies to scale up their code. The serverless vendor handles all of the scaling on demand. Next is the simplified backend code. With FAAS, developers can create simple functions that independently perform a single purpose like making an API call. Quicker turnaround. Serverless architecture can significantly cut time to market. Instead of needing a complicated deploy process to roll out bug fixes and new features, developers can add and modify code on a piecemeal basis. How does serverless compare to other cloud backend models? A couple of technologies that are often conflated with serverless computing are backend as a service and platform as a service. Although they share similarities, these models do not necessarily meet the requirements of serverless. Backend as a service is a service model where a cloud provider offers back-end services such as data storage so that developers can focus on writing front-end code. But while serverless applications are event-driven and run on the edge, BaaS applications may not meet either of these requirements. Platform as a service is a model where developers essentially rent all the necessary tools to develop and deploy applications from a cloud provider, including things like operating systems and middleware. However, PaaS applications are not as easily scalable as serverless applications. PaaS also don't necessarily run on the edge and often have a noticeable startup delay that isn't present in serverless applications. Infrastructure as a service is a catch is a catch-all term for cloud vendors hosting infrastructure on behalf of their customers. IaaS providers may offer serverless functionality, but the terms are not synonymous.